Start.
Hello everyone, we're Group 127 from NCSU. I'm Rohan, and with me in our group we have Rahil and Karan. Today we'll show how we made CAPTCHAs more accessible for dyslexic and visually impaired users using neural networks. Talking about the motivation, CAPTCHAs do secure the web, but this distorted text and color cues block dyslexic or colorblind users, and we aim to maintain the security while improving the accessibility. Talking about the problem statement, our goal is to not break captchas, but is to help real users. The inputs are captcha images, which can be grayscale or colored, and the outputs are predicted character strings. We track both per character and full string accuracy to mirror real usage. Having further into dataset, we gathered around 113,000 captchas from Kaggle and from a synthetic generator which varies fonts, distortions, noise, and color cues. Also, we made sure to implement data augmentation techniques like rotation, skew, contrast. This ensured robustness to the unsealed style that may come up. We made sure to perform exploitative data analysis. This helped us further understand our dataset and samples showed overlapping characters, nice lines, ambiguous pairs, and we made sure to clean the labels and to reduce the ambiguity, thus to improve the model training. For example, this is one of our methods of EDA. We worked on color channel analysis. We can say that RGB histograms reveal heavy red-green bias, problematic for colorblind users, and poor text background contrast. This led us to add adaptive contrast filters and a grayscale path. Further talking about pre-processing, we created a pipeline that converts grayscale to Gaussian blur and also implements binarization and also make sure that it resizes to 100 by 50, ultimately normalizing our data. The labels use embeddings to capture character similarity without confusion. Now Rahil will continue.
Coming to the baseline model. Our starter model had two convolution ReLU max pull blocks and one FC layer and four softmax heights, trained with Adam for 30 epochs at batch 128. It provided a solid but improvable baseline. These are the evaluation metrics we measured per character accuracy, partial accuracy, and full captcha accuracy. These were the results 87%, 79%, and 68%. Coming to the model improvements which we did were few were that we added batch normalizations. After each convolution, we introduced residual connections for gradient flow and we increased the depth of convolution blocks to 4. We enhanced the augmentation and added a learning rate as well as a early stopping. So this is our final CNN architecture. Input is 50x100x1 grayscale image, 4 times convolution batch normalization, ReLU and max pull blocks, residual skip between convolution blocks 2 and 3, and a full connected layer with dropout 0.5. And the output was a 5 parallel softmax output side. These changes, method changes on accuracy impact. We added batch normalization, which gave us around plus 2% per character accuracy. This residual connection gave around plus 1% per character accuracy. Increasing depth gave us around plus 3% full captcha accuracy. Augmentation gave us plus 3% robustness to distortions. And schedule and early stopping gave around plus 1% generalization, which reduced overfitting. This is the final performance comparison. As we saw, baseline was 87, but improved CNN became 92. For full capture, it was 68, which became 78, and for partial accuracy, it was 79 and it became 87. Future scope is that next step is depth-wise separable convolution networks for mobile, transformer attention for sequential modeling, and on-device real-time assistant. User studies with target groups could also help us improve our model. And final support for multilingual and or audio captures could be added to this. Coming to previous experience of team, we had some prior experience in computer vision as well as deep learning image, and this we also had some prior experience in with CNNs, ResNet, noise reductions, and some pre-processing techniques which supported us during this project. These are the references for our project. Thank you very much.
Thank you.